So now that we have the physics of the simulation set up for a boring little black ball, what we want to do and what we're going to accomplish in this video is create the bird and basically replace this black ball with the bird. All right, so let's get started. Create the bird. So this is a little bit tricky. The key insight here is we are going to be making a bunch of ellipses. And the formula for an ellipse is that you specify the x values to be a sine and the y values to be cosine, or you can also do it the other way around. And you specify sine and cosine to go between 0 and 2 pi, and then you plot x against y. All right, so I realize that's vague, that's just a bunch of words. Let's just get started and see what happens. So I'm going to say body x equals 3, actually let me just start like this. I'll just start sine lin space. I'm going to go linearly spaced numbers from 0 to 2 pi. And how many points should we go between 0 and 2 pi? Well, that's a parameter, so let's call this n. Let's call it n per part equals, let's set this to be 50. So we have 50 points like this, and then I'm going to set the y values to be also, so let's set this to be cosine. Okay, and now I'm going to say plot body x by body y, and we'll start off with these being squares connected by a line. All right, so you can see that this makes a nice circle like this. Now, this is a unit circle, and if we want to make this into an ellipse, then we can scale this equation by some factor. So I'm going to scale the cosine by 5, let's say, and scale the sine by 3. Now, this still kind of looks like a perfect circle, but if you look at the axes, you'll see it's actually not a perfect circle. So I'm going to say set get current axis. The x-lim will go from -5 to 5. And then the y-lim will also go from -5 to +5. And now you can see that this is an ellipse. It's an oval. But if we want this to be the body of the bird, then this is actually going the wrong way. We want the bird to be standing up. So I'm going to swap this here. So this is going to be 3 on cosine and then 5 on sine. And this should also make sense. The y-axis coordinates are stretched more compared to the x-coordinates, which are stretched only a little bit. So now this is going to be the body of the bird. So let me make a comment in here. So this is going to be specify x, y points for the body. Now it turns out, for reasons that will become clear later, it's going to be useful to have this not as a row vector, but as a column vector. Okay, so this is the xy coordinates for the body. Now I'm going to do a little bit of copy pasting. Now I'm going to create the head. Now, how should we create the head? Well, first of all, I'm going to make the head be a perfect circle, and it should be smaller. So it turns out that 1.5 is pretty good here. And let's plot this. So I'm going to say clear the figure and then hold on. So the body, let's make in black. And then I'm going to plot the head x and head y, and we'll set this to be about red circles. Also that are connected by a line like this. Okay, and then this has to be changed from body to head. All right. So how does this look? So it looks like the head is exactly in the center of the body, which is not exactly the right thing. So what we need to do is shift this head so it's further up here. So we want to shift up on the y-axis. So I'm going to shift there by 5. That's going to put it on top here. So I can show you this, but that gets cut off. So let's make this go, how about -5 is okay, and then +7. How about that? Oh, that was X. I meant to change Y. Okay, so that looks a little bit better. And I think it's also useful if the head is kind of, in front of the body a bit. So I'm also going to add an offset to the X coordinate. So the Y coordinate, I add an offset of 5. And here I'm going to add an offset of 1. Okay, so that looks pretty good. We still need to color the inside and do a couple more things. But first I want to try adding a wing. So the wing is going to be another ellipse, and that's going to go here. So that's going to be a long, tall, skinny ellipse that's going to be shifted just a little bit negative from x equals 0. All right, so copy and paste. This is going to be the wing. And let's see, I'll call this wing x and wing y. And here it turns out that, let's see, we want the y to be longer. So let's try multiplying that by 4. And the x is going to be shorter. And I think we'll actually just leave it like this. So let's already just plot this like this. So I'm going to copy paste and say this should be wing and this should be wing. And let's make these, how about green diamonds? That's not a diamond, that's a triangle, but that's okay. All right, so this is looking pretty good, except it's centered. So I want to shift this on the x-axis by -1. So I'm going to subtract 1, plot it again, and great. This looks pretty good. Again, as I mentioned in the previous video, you have to use your imagination a little bit. So this is the body of the bird, the head, and the wing. Now, when we get to the final simulation, we are going to want to have only non-negative values for all the coordinates. So what I want to do is basically shift the entire bird, shift all 3 of these components, the body, the head, and the wing, so that they're all pushed up this way. So this point here should correspond to 0, and this point here should correspond to y equals 0. So we can do this by finding the smallest value, the most negative value in the body, because I know that's the most extreme part, and then basically shifting all of the other xy coordinates according to these minimum values. So let's see, shift all points to be positive, or I should say non-negative. So we need the lowest point, and the lowest point is basically the minimum of the body in the y coordinates. That's min body y. And then we want the leftmost point, and I'm just going to leave out the t here. And the reason why I'm leaving out the t is because I think code looks nicer when it's all aligned like this. So if you actually wrote left in here, you get this misalignment. I find this to be visually cleaner this way. Okay, and now we want to subtract the left point from all the x coordinates and the low point from all the y coordinates. So that's going to be body x equals body x minus the left point. And same thing for head and wing. So that's for wing and head. This is head, and that's wing. So now before shifting this also up, let's already try to run this and see if it looks good. All right, this looks good. So now you see that the leftmost point of the bird is aligned with 0. So now I'm going to repeat this procedure for the lowest point here. So this is, change all the x's to y's. And then the left point to low point. Run this whole thing again, and overall this is starting to look really good. So I'm going to change this. Let's set this to be 0 to 10, let's say. And this can also be 0 to 10. Nope, 10 is not quite enough. So y, that needs to go up to, let's say, 15. But then this should be equal. All right. Looking good. This is our bird here. It's getting better slowly. And now the thing is, we don't actually want to plot these like this. We want these to be filled shapes, filled polygons. And so I'm going to use the patch function. So in fact, I'm going to delete all of this. That was just for testing. So I'm going to say patch the head X and head Y, make this blue. So this is going to create a patch of the head. So it's a circle and it's all in blue. In case you are not familiar with the patch command, essentially what you input is a list of X coordinates and a list of Y coordinates. And MATLAB is going to draw a polygon. In this case, it's a circle, but more generally, it's going to be a polygon. It's going to trace around all of these X and Y values all the way around like this, and it's going to fill the shape according to this color. Now, this is the thing, this is the object that we want to access later when we are moving our stoic bird around on the screen. So I need a handle. I'll call this head H. So it's the head of the bird, and then H for the handle. And that will allow me to adjust the X values and the Y values. So let's see, we don't see that here. So here's the X data and the Y data. And later on, when we incorporate the physics, I'm going to be changing the X data and the Y data. All right, so this is for the head. Then I can say copy, paste, paste. So we need for the wing, and this is going to be for the body. So then I need to adjust this. Whenever you're copying and pasting like this in MATLAB, it's always really important to make sure that you are updating any coordinates that you need to. For example, it can be really easy to make this mistake where you accidentally forget to update this part. And then you're going to get a really weird looking bird. Actually, you know, this also looks kind of neat, but it's not the kind of bird that we're looking for. I also need to change the colors here. So let's see, the body was red and the wing was yellow. Right, so this is not correct. This needs to be wing Y. And now I'm going to set the axis to be -1, +1, -1, +1 times 10. Let's see if that works. Right, so actually this should be 0, and then 0, and then let's try this as 20. Great, so here's our bird. It looks really good. It looks very stoic and emotionless. And you'll notice that the order in which you draw these patches is important. So if I would put the head down here below the body, then it's actually going to come on top. So I actually meant below in terms of the spatial organization of this line of code. So if I first draw the body and then draw the head goes on top of the body. Now, visually, this also looks fine, but you have to be careful. For example, if you would draw the wings first, then the body is actually being plotted on top of the wings. So that's not good. So if you prefer to have the head on front, let's see, and how did that look here? Yeah, maybe it does actually look better like this. I think we'll leave it like this. Now we have the bird, and what I want to do now is integrate the physics that we discovered, well, we didn't discover it, but we figured out how to program this from the previous video. So let's see, I'm going to copy these same physics variables in here. So these are the physics constants. Now we still need X and Y here because those are the initial positions of all of these coordinates. So just to be clear where we are here, I defined lots of X and Y coordinates, so 150 X and Y coordinates that define the bird. And then we have this X and Y coordinate, which defines the starting position of the bird. And now what we want to do is basically run this animation. It's going to look almost exactly like this, except instead of only updating one X and one Y position, we need to update all of these XY locations simultaneously. All right, so I'm going to copy all of this and paste this down here. So the question is, what do we need to change in this code here, in this while loop? And the answer is, we don't need to change the pausing part, of course, and we actually don't need to change this, the X and Y coordinates. Those stay exactly the same. The formulas stay the same. All of this stuff stays the same. The only thing that we need to change is this set function. So instead of just setting H, that was the handle to one ball from the previous video, we need to update the handles to all of these objects, to these patch objects. So that was body H, head H, and wing H. So let's start with the body. So I'm going to say body H, so that's the handle that we want to update. And the X data will be, this is a little confusing, but follow along with me, head X plus X. So the idea is head X, this defines all of the relative locations for, in this case, the head. So just the head here, these X coordinates. And then we're adding to that this X offset. And this X offset is defined by the projectile physics. And then it's the same thing here. So this is going to be head Y plus Y. All right, so let me see. I'm going to run this code, and this actually needs to be scaled up quite a bit. So let's, oops, not 10, 100. And now I'm going to reinitialize X and Y here and run this code here. All right, so that's pretty neat. Now I just realized that there's a little programming error, so it's a good thing we stopped to check out this simulation. You might have noticed that actually the head stayed the same, that was the blue ball here, and it was the body that actually moved. So what I did was update the body handle using the head coordinates. So that's kind of funny. And it's a good thing that I was meticulously checking the results after each time I changed something in the code. This is a super easy mistake to make. So it's good to check your code frequently to make sure you avoid or find and fix those mistakes. Okay, let's see. So we want the head and the body and the wings. So this is going to be body handle, and then this is going to be body X and body Y, and then this is going to be wing Y, wing X, and the wing handle, wing. Okay, so now I'm going to reset this, and let's rerun this and see if that works. All right, this looks really good. It moved up here, it started up here, corresponding to X equals 0 and Y equals 70. And then the stoic bird kind of was pushed out this way and it gently fell down over here. Great, so that was quite an achievement. We are working towards our final goal. In the next video, we are going to create the GUI to run the simulation, and then thereafter we will get to install functionality onto the GUI, including all of the code that we generated here together. I'll see you in the next video.